Hey everybody, welcome to Activity 2.2, Systems and Contact Forces. So where do you find this activity? It depends on what year it is. Sometimes we do it out of our book, but sometimes the book has a few glitches in it. So sometimes we actually do a paper copy. So whatever your teacher gives you or whatever your teacher informs you to do, that's what you're going to be doing. So in science, what makes something a system? If you remember back in our last book, when we were taking the basketball and we were bouncing the basketball by itself, then we bounced the tennis ball by itself, then we bounced the basketball and the tennis ball together. And what you found was that when the basketball bounced with the tennis ball, in other words, the tennis ball was on top of the basketball, it didn't bounce as high. Where did that energy go? Well, obviously it went from the basketball into the tennis ball because the tennis ball went a lot higher when bounced with the basketball. And we talked about systems with that lesson or that activity, where if you put the tennis ball and the basketball together, no energy is lost. It just got transferred from one into another. And then if we include the air, we include the floor, energy is lost into the system. So we've learned that energy cannot be created nor destroyed. If it seems to have disappeared, it goes somewhere else within a system. So when we talk about systems, and you remember activity 2.1 we just completed, each of the four devices in activity 2.1 can be called a system because it is composed of multiple components that interact with each other. So if you think of, say, the fan car, it doesn't do us any good to think of the wheels, the axle, the little car, the fan on top, all is separate. The magnetic cannon, it doesn't pay for us to look at every component, every little piece is separate. We can and we will break down, say, the magnetic cannon, but we want to look at the whole. And that's what a system is. And that's what we're going to look at today. And here's the scenario. We've got a vehicle that's stuck. So let's just pretend for a second that you took a vehicle, you were driving it in the backwoods, and you got stuck in a mud pit. So someone else has come along and they're going to try and pull you out with a Yankum rope. So consider a vehicle trying to pull another vehicle with a rope. One of the vehicles is stuck in mud. What are the components of the entire system that influences motion? So if we look at the picture, think about what are the different systems? We got one vehicle. We got a second vehicle. We've got the rope. We've got the ground. And then we're going to be talking about one other part that people don't often consider when we think of physics. So again, the two vehicles, rope connecting them, the ground or the mud, and the planet Earth. You might be thinking, why the Earth? We're already talking about the mud, that's the Earth, right? Well, whenever we talk about the Earth, we are thinking of gravity. Gravity pulling things down. And that's important to know when we're dealing with forces. So the first thing I want you to do is look at this component. And I'm going to come back to this picture. What I want you to do is draw a simple model of the two vehicles and the rope connecting them. Now in class, I'm only going to give the kids about 2 minutes. What I'm going to tell you to do is draw a simple model of the two vehicles and the rope connecting them. Pause the video, take as much time as you need, draw this. If you're in class, it shouldn't take more than 2 minutes, otherwise you're going to fall behind. So go ahead, draw a model. All right, so you have the video on pause now. And we're not necessarily going to talk much about your model now because we're actually going to take a look at the model again towards the end of class. So the first thing we're going to do is we're going to create an interaction table. And an interaction table helps us create the model. And I'll show you how it's going to help us create the model in a little bit. So it's going to help us create our models. So what I need to do is I'm going to grab a pen. And let's go with green. And what we're going to do is which components of this system interact with each other. So these are the different components that we talked about. And we're going to place a plus in a box for components that interact with each other, and an X or a minus sign, not an X, in the box where components do not interact. So does vehicle 1 interact with a rope? So if we go back to this, does vehicle 1 interact with a rope? Yeah, they're touching. So go ahead and draw in a plus there. Does vehicle 1 interact with vehicle 2? Now this is where people say, well, yeah, they are. Well, no, they're not. Vehicle 1 and vehicle 2 are both interacting with the rope, but they're not interacting with each other. So for this one, I'm going to put a minus. Does vehicle 1 interact with the ground? Yeah, it's on the ground. And does it interact with the earth? In other words, is gravity pulling down on vehicle 1? Absolutely. So let's go through this. Does the rope interact with vehicle 2? Yep, they're touching. Now, does the rope interact with the ground? If we look at this, does rope interact with the ground? No. If they're truly pulling on it, no, it's not touching the ground. Does does the rope interact with the earth? In other words, is gravity pulling down on a rope? Yeah, gravity pulls down on everything. So let's look at vehicle 2. So we don't have to talk about how they interact with these because it was already taking place up there. So vehicle 2, does it interact with the ground? Yep, vehicle 2 is on the ground. And is gravity pulling down on vehicle 2? Yes. Does vehicle 2 pull down on the ground? That's where some people say, well, the ground is the earth. Well, think of earth as just gravity. So yes, it pulls down. If a little mud goes flying up in the air, gravity is going to pull it back down. Now, I might be looking on here and say, well, we have a lot to do. Well, really, we don't. This vehicle column right here is the same as this. So I can just copy these that I see up above there. Rope right here is the same as this one right here. So it's plus, minus, plus. Plus, minus, plus. This makes it really simple. We look at vehicle 2, it's plus, plus. Vehicle 2, it's the same thing going down there. Now, I believe on the tests I actually have these grayed out. So you don't actually have to do them twice. So that's kind of a nice thing. But they are there. So if you ever see an interaction table, you have to fill one out. You know what they're for. Now, I want to point this out right here. A force that is the result of two objects touching each other is called a contact force. And that's going to be important because later on we're going to draw a model, the same model that you drew. We're going to perfect your model, but we're going to add some arrows to it. And those are going to be contact force arrows. And why we say they're contact forces, we're going to draw non-contact force arrows in a different activity later on. So yours should look like this. So double check, make sure you have everything correct. So look on your paper. We're going to go through a series of questions that you're going to have to answer. So when people push each other, is there one force acting or two? So let me get rid of that line. Let me get this back. There's actually two arrows. They're pointing in opposite directions. So if you're pushing on someone, they're pushing back. If you push on a wall, the wall pushes back. So this should be two. How about this scenario? What do you think? How many forces does each person apply? One. So this hand is pushing in this direction on this hand, and this hand is pushing back. Or if you were to grab each other's hands and you're pulling, it would be the same way. You only apply the one force. How about this question? How many forces act on each person? Well, it's got to be the same thing. If each person applies a force, they're applying the force on the other person. So each person has one force acting on them. I guess that's the easiest way to see it. All right. So let's apply what we've learned. So for this, think about it. If this person was pushing on the wall, and if we were to add arrows to this to show contact forces, we know this person's pushing on the wall. What is the wall doing? The wall's pushing back. Technically speaking, that's true. But don't go to the office and complain. The wall pushed me. Now, some people would say, well, you should have it for this hand too. Okay. But overall, we would say you applied a force to the wall pushed back. I'm not necessarily going to say, well, there's two forces, one from each hand. This is a little bit trickier. What do you think? Ladder's pushing on the wall, and the wall's pushing back. But what about this? Here, the ladder's pushing down. And what's the floor doing? It's pushing back. Now, these are all just contact forces, because if we start talking about non-contact forces, we know gravity is also pulling down on the ladder. And the ladder is also pulling up on the earth, but we're only drawing in contact forces. Same thing with the shoes. The shoe's pushing down on this shelf, and the shelf is pushing up on the shoe. So does this make sense? So let's apply a little bit more. Oop, don't look, turn away. So when you sit in your chair, do you push down on it? Absolutely. Now, does your chair push up on you? Yes, absolutely. And today is one of those rare days where if you just want to put yes, yes, no, no, yes for your answers, I'm okay with that. Because these are such short answers. The book doesn't do a really good job of saying explain, explain, explain. So I can understand if you only had one word answers. All right. So now we're back to I. So did you get all these? Oh, there's one more underneath there. Can you think of an example where contact forces are not paired? And the answer is that if you really think hard about it, there are none. There are no examples of forces always, or forces just acting in one direction. You push in the wall pushes back. When you walk, you push down on the floor pushes back. When you sit in your chair, you push down on the chair pushes back. The chair is on the floor, it's pushing on the floor is pushing back. So forces always come in pairs. All right, so now here we go. I. Return to the model you drew of the two vehicles in a row. Add pairs of forces to the model. So this is what I would say. If you go back up to your original model and your model was correct like this, just go ahead and go draw it up there. If your model was not correct, go ahead, quickly draw this in. Sketch it in on your paper. All right, pause if you need more time, but we're going to move on. So return to the model you drew of the two vehicles in a row. Add pairs of forces to the model. So again, if I get my pen back out, and if I draw in forces, now was vehicle 2 applying, or vehicle 1, were they applying forces to the rope? Absolutely. The rope was applying, the vehicle was actually pulling on the rope, and the rope was actually pulling back. So this would be the direction of force. So the vehicle is actually pulling on a rope. The rope's actually pulling back. Same thing here. They come in pairs. Rope's pulling on the vehicle is pulling on the rope. How about the ground? While vehicle 1 is pushing down on the ground, and the ground is actually pushing back up. There was no contact here with the rope, but look over here. Same thing here. Now, we're going to talk about this a little bit later, and I'm going to actually show you this. These are just contact forces. What would the non-contact forces be? It would be gravity. And I'm going to show you these. You don't have to have them on your paper, but you can add them if you want. These are actually represented by dashed arrow. So vehicle 1 is actually pushing up on the earth, or pulling up on the earth, and the earth is actually pulling down on vehicle 1. Same thing for the rope. The rope is actually pulling up on the earth, and the earth is pulling down on the rope. Same thing for vehicle 2. So you can see we get lots of arrows in here. Now I'm missing something. Gravity is actually pulling down on the rope, and the rope is actually pulling up on the earth. So I have to have those sets of arrows. So now watch this. If I count this sets of arrows, 1, 2, 3, 4, 5, 6, 7, 8. And if we go back to this right here, 1, 2, 3, 4, 5, 6, 7, 8. Or let's count this way. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 sets of arrows. There's 8 sets of arrows. Now a little bit more about this. Horizontal arrows show horizontal forces. Vertical arrows show vertical forces. Lines, arrows that are not dotted or not dashed are contact forces. These would be non-contact forces. We're going to learn more about those. But this is important because what you can't do is, I don't ever want you to, say, oh, I'm going to draw an arrow like this. That doesn't work. Is that a vertical force? Is that a horizontal force? So I've got to get rid of this. Again, horizontal arrows show horizontal forces, and the arrows point. So this one right here is technically for the vehicle pulling on a rope. So if I put the answer key up, you had all those first ones. And then we drew in those dashed arrows, which you don't have to have yet, but I just wanted to fully explain that. So here's our last question. Oop, I didn't cover that one up either. What can you conclude about pairs of forces, pushes, and pulls, and the directions of forces? First of all, contact forces always come in pairs and in opposite directions. If I pull on the rope pulls on me, the arrows go in opposite directions. Horizontal forces are shown by horizontal arrows, and a horizontal force is going to have an opposite horizontal force acting on it. So, all contact forces, pushes or pulls, come in pairs. If one force is a push, then the other one will be a push as well. If one is a pull, the other one will also be a pull. This means that the pairs always come in opposite directions. So, there's a lot to this, and there's going to be a lot built into the first several activities in this book. So make sure you're paying attention. Make sure you're actually listening to the video of me talking, especially if you don't have earbuds. Otherwise, that's one of the reasons why we sometimes don't do well on activities and tests. As always, if you have any questions, just ask them. Thanks. Have a great day.